Hello class. Today we're going to learn some trig, I guess you could say trig formulas. It's called the sum and difference formulas. I want to say you should have learned this in geometry or maybe algebra 2, but then you guys will get mad and say, no, we didn't. So we're going to start from the ground floor and pretend that you never heard of the sum and difference formulas. Right now I'm giving you this table right here in the middle, and eventually I'm taking this away from you. As a matter of fact, I don't think I'm going to have you use it at all for the exam. But I'm going to teach you how to remember it, etc., etc., etc. What you're going to do, or you learn today, is like how to use it to evaluate trig functions, and then we're also going to use it how to verify identities, just like we learned in the last section. Sum and difference formulas are very simple. If I have essentially two angles and I'm adding them within a sine or within a cosine, adding or subtracting, I could simplify it into a formula like so. Again, I'll teach you how to memorize it. Same thing with tangent. And the reason why we use these formulas, and I'll show you why also, is because some of these formulas you should know by heart, or some of these formulas, some of these special triangles you should know already. And some of you will not know them, but we'll practice. Okay? So let me show you here at the bottom. It says evaluating a trig function. It says exact value of cosine 75 degrees. I know you could just put this in the calculator and you'll get an answer, but they want the exact value. Okay? So what are we going to do? Well, I'm going to use one of my sum and difference formulas. See how this is cosine 75 degrees? Remember, in the special triangles, are the ones you should know, and the ones that we use on the unit circle, you should know 30, you should know 60, and you should know 45. Those are the special angles, the ones that we have memorized. Would you agree that cosine 75 means the exact same thing as 45 plus 30? Okay. So what I'm going to do, see how this is cosine 75? I'm going to use this formula right here. And instead of saying cosine 75, I'll do cosine 30 plus 45. Okay, so far? Because they want me to find cosine 75, wouldn't you agree that finding cosine 30 plus 45, these two mean the exact same thing? Okay. If that is the case, I can now apply my formula. The formula says take the cosine of the first one and the cosine of the second one. Okay, so far? Then it says minus sine of the first one and sine of the second one. And that's all it is to plug in the formula. Now, you could use your unit circle, and eventually I'm going to take it away from you. Or you could use these special triangles. They usually have this at the beginning of the SAT to figure out what these values are. Cosine of 30 is radical 3 over 2. And again, you could use your unit circle. Cosine of 45 is radical 2 over 2. Sine of 30 is half, and sine of 45 is also radical 2 over 2. So do you see how all I did was find these values using the unit circle or using these triangles? Now I'll multiply across, these ones are multiplication. I have to do multiplication first. Radical 3 times radical 2 is going to be radical 6 over 2. And here I get radical 6 over 4. So I'm multiplying. And this one I'm going to get radical 2 over 4. And now I'm running out of space. Let me just move this up. Radical 2 over 4. Okay. It says I have radical 6 over 4, and I'm subtracting radical 2 over 4. I have the exact same denominator, so I could just combine them. And my answer is going to be radical 6 minus radical 2 all over 4. Okay. Exact same thing happens for radians. So this one is in degrees, and it's probably very easy for you to understand. But now let's do it. What if it was in radians? Now I have pi over 12. Okay. Now you got to think about what adds or what subtracts to give me pi over 12. Okay. A little bit trickier. Okay. Would you agree that? Would you agree with me, and maybe you don't agree with me, and again, it'll take a little bit of practice. Pi over 12 means the exact same thing as pi over 3 minus pi over 4. If you don't believe me, I could give you a simple proof. And again, this is just something that you'll get used to. If I did pi over 3 minus pi over 4, and I found a common denominator, this one would be 4 pi over 12, and this would be 3 pi over 12. Yeah, and then the whole thing means pi over 12. So you don't have to believe me, and again, this is practice. I mean, you'll see you'll see pi over 12 a lot. You should know that pi over 12 means the same thing as pi over 3 minus pi over 4. Okay. I'm trying to find sine, so what I'm going to do is I'm going to use my sine formula. Let me just move this real quick. So sine of pi over 3 minus pi over 4, which again means the same thing as finding sine of pi 12, right? These right here mean the exact same thing, equals, and now I'm just going to apply this formula, sine of the first one, cosine of the second one, minus cosine of the first one. I'm running out of space here, but sine of the second one. So all I did was plug into this formula right here. So again, you could use your special triangles, you could use your unit circle. Sine of pi over 3, remember, is 60 degrees, radical 3 over 2. Cosine of pi over 4, or anything pi over 4, is radical 2 over 2. Cosine of pi over 3, or cosine of 60, is 1/2. And then sine of pi over 4 is always radical 2 over 2. You'll notice I have a very similar answer to what we've been working on. Let me just move some of this real quick. This becomes radical 6 over 4. Whoops. This becomes radical 2 over 4. I have a common denominator, so all I can do is just subtract across. My answer is going to be radical 6 minus radical 2 all over 4. And then I just have one last example that I want to practice, and again, we'll do this in class, but you could also work in reverse. Here's an example of something that I have no idea how to do in my head. I don't know how to do sine of 42, I don't know how to do cosine of 12. I definitely don't know how to multiply them if I don't even know them individually. So I'm going to look at my formulas and see if any of them match what is given in example 3. So you see sine, cosine, minus cosine, sine. And I notice the one that matches that is this one. So here, again, my problem says sine, cosine, minus cosine, sine. And I notice in my formula, this is the one that matches that. If I ever get that problem, I could just simplify it into sine of the first degree minus the second degree. So all I'm saying is that this, in this format, means the exact same thing as sine of the first degree minus the second degree. 42 degrees minus 12 degrees is 30 degrees. And then sine of 30 is 1/2. So that is one simple way, or one tangible way, obviously I don't know when you would see this, but where I could find the problem or express this problem in simple terms rather than put it into a calculator. Again, I don't know when you would see it personally, but there are instances in engineering or in medical fields where you might see something like this and you can easily quantify it into a simple number. So hopefully that helped y'all understand these formulas. I'm going to teach you how to memorize it the next time I see you in class. But really it's as simple as just recognizing a number, finding out what adds or subtracts to it. Remember 75 was the same thing as 30 plus 45. Remember pi over 12, again, you might not know this, but we'll practice, was the same thing as pi over 3 minus pi over 4. And then working in reverse, if I have the formula, I identified it using the table. It was the same thing as 42 minus 12, which is the same thing as 30, was equal to 1/2. So this is a shorter video than you're used to, but this is all I just wanted you to learn for now. Have a good day.